Hey guys, Gary from DIY Electronics. I had a subscriber ask me if I could give him a brief explanation of putting batteries in parallel and putting batteries in series. And I've got a little example right here on the desk for you. And what basically you're doing with your batteries are is if you're putting it in parallel, okay, you're going to keep the voltage constant all the way across. So if it's 12 volt batteries that you're putting in parallel, that's what you're going to get out at the end is 12 volts. But if you're using 12 volt batteries and you put it in series, you're going to get voltage that is additive, meaning that the first battery is 12 volts, the next battery you add in series go to 24 volts, the next battery that you add in will go to 36 volts, so on and so forth as you add them up. The most common way to put batteries is, I would say it's in parallel, because parallel keeps the voltage constant, and also parallel will increase your capacitance. Meaning that if this is 7 amps, this is 7 amps, this is 7 amps, you're going to get 21 amp hours out of your 12 volt batteries. If this was in series, you would only get, so say that this is 7, 7, 7, you're only going to get 7 amp hours of capacitance. In series, it's not additive, it's additive in voltage, but not additive in capacitance, where in parallel, it's additive capacitance. Okay, so it's the best way to use batteries is really in parallel. So let me just show you what I've got going on with these three batteries. Let me just reposition you. And what we're going to do first is we're going to meter out each one of the batteries. All right. This is 12 volt lead acid, 12 volt lead acid, 12 volt lead acid. This is 19 amp hours. This is 7 amp hours, and this is 7 amp hours. All right. I believe my first battery is only has like 9 or 10 volts in it. So let's take a peek. 9 volts. 12.75 volts. 12.53 volts. All right. So let's get series out of the way first. Okay. So now remember that series is additive. So if this is 12, 24, and what was this, 9? So this is, once I put these all in series, it's going to be around 30, 32 volts. Let's see what happens. So to put these in series, you have to go from your starting battery. Let's get back to here. Your starting battery, I'm going to go and put my jumper on the positive. The next battery in line, I'm going to put my jumper on negative. So this battery goes from positive to negative. Then to connect my next battery, I'm going to go from the positive of this battery to the negative of the next battery. All right. Now to get your total voltage, you got to go from the two open terminals of your series circuit. So that would be the negative of this end battery and the positive of this end battery and the negative of this end battery. So let me go on negative and let's go positive. Yeah, 34.56 volts. Okay, that's the addition of all three of these batteries. Okay, now remember, this battery is only 7 amp hours. This is 7 amp hours. This is 19. So once the 7 amp hours is drawn out of this, the battery goes dead. It's not additive like it is in a parallel circuit, and I'm going to explain that next. So again, for a series circuit, go from positive, negative, positive, negative, and your two open terminals is your final outcome voltage. All right. So that in essence is a series circuit for batteries. All right. So now let me pull these off, and now we're going to do a parallel circuit, and I don't have enough jumpers. So I'll just do it with two batteries. All right, so let me get this one. I'll take this one out of the equation, and we'll use just 2 batteries. Now remember, on a parallel circuit, your battery voltage does not ramp up. It stays continuous. It's going to stay at the highest battery. All right, so let's meter this out. We got 12.52, 12.7 is 5, so I think when I put these in parallel, we're going to get somewhere around, I'm going to say about 12.6. Now to put them in parallel, you take a positive jumper, and you guessed it, go positive to positive, and then go from negative to negative. All right, and now where you test your voltage, you can do it on either end. Okay, you can go from here or over here. And what do we get? I was off. 12.73. All right, and we'll go up here. 12.54. All right, so, and what's going to happen is this is 19 amp hours and this is 7 amp hours. So between these two, you will get your full 26 amp hours of capacitance. All right, putting them in parallel. All right, because basically both of them are going to drain at the same time, and their amperage is going to go down, because if this one starts losing its amperage, this one, it's going to draw off of this one. So it's going to use its continuous 26 amps until the whole 26 amps of power or capacitance is gone. All right, that's the advantage of putting your batteries in parallel. There's not really that many applications for putting batteries in series, unless you're doing, sit here so you can talk to me here, that series is, you see that in like solar arrays and stuff like that for batteries. All right, so that, guys, is the long and short of it on how to put batteries in parallel and batteries in series. Okay, that's all I got for you. Hope this helps. Ring the bell, subscribe, like, and just hit all the buttons. Thanks for watching, guys. Gotta find my mouse here.